Hello everyone, welcome back to my channel. Today let's go over a Leetcode medium question that I just solved on my own. So I'm really happy about this because it took me quite a few tries, but I was able to solve it without any assistance. So I'm pretty proud of that. Although I hit time limit exceeded a couple of times, I again was able to do it. So let me show you how I did it. So this one's called smallest palindromic rearrangement 1. So you're given a palindromic string called S, and you want to return the lexicographically smallest palindromic permutation of S. So let's rearrange it in any way possible, and then whatever is the smallest alphabetical order, return that. So let me show you the brute force way of doing this, which is pretty simple. Just generate a sorted list, and then just go through. I don't know why the return bar never works on Leetcode. Considering I'm paying for premium, they should have a better user experience, but some things are just the way they are. So generate all permutations of S, and then just add a string version of this tuple that's generated, and then just return. Well, so if A is a permutation, meaning the same as the reverse, then do this, and then run it. So that should work, but obviously this is like exponential complexity because you're generating each and every permutation. So race car or this is a permutation because if you read the same backwards, the same forward, that's what this is for. And then this is just turning the tuple back into a string. So you get time limit exceeded because that's really slow. So let me show you what I did instead, which is if you make some observations, you only have to generate the first half of the string, and then you try to make the reverse of that in the second half, and then add whatever's remaining here. So here, ACD, try to generate ACD flipped around because we want a permutation that has to be the same. And then this is the first half is already in sorted order. So hopefully that makes sense. So, okay, so if we know that, it's easier because we can generate half of the string. So if length of S is an even number, then the half is just going to be this. Otherwise, half is going to be -1. And let's print S up to half, including half. Cool. So when you have an odd number, don't go up to half. When you have an even number, do go up to half. Let's see. So if it's even, or, okay, I guess you don't even have to do that. So we get the first half, which we call it this. And then we want to sort this, right? So turn it into a string, sorted of this. Let's print first half. Cool. So now our job is just to make the second half. So the second half is just going to be S of half to the end, because this is up to not including this. Let's call this second half. Cool. So now we want to somehow rearrange first and second half in a way that, so we want to make this flipped around. If we have that, so AB exists here, here ACD exists here, like the frequency is the same. So that's what we're going to do. And then we're going to pop the remainder in the middle at the end. So just 1B, right? Because the left and the right half are literally flipped around. That's the point. And then you have 1 in the middle. So that's how permutations work, or palindromes work. So cool. So now let's just try to generate second half. So for I in range length first half. So let's call this second is list of second half. If first half of I is in second, then what we're going to do, again, we want it to be reversed. So this to the end, this to the end. So we're going to say Q is a deck, Q dot append left of first half of I. And then we're just going to remove first half of I. So then let's print first half in Q. And let's also print second. So cool. So now you can see we have exactly what we need, because now we have one letter in the middle. This is exactly the reverse. This is exactly the reverse. In this case, we have nothing in the middle. So what we can do is just return first half plus a string of second plus a string of the cube. So submit this. So again, append left just takes this and says, okay, we're going to add it to the front. We're going to add it to the front. We're going to add it to the front. So you get time limit exceeded. That's good. Now we got the core algorithm. Now it's just a matter of optimization. This is really slow. So we're just going to, instead of in second, that's also n. This is n. So that's really slow. So we're just going to create a counter of second. And let's say if it's in C. So we just keep track of the frequency. So in that case, C first half of I minus equal to 1. So we get the number like A, how many times it appears. So we're decrementing this to become 1. And then if this is ever 0, then it doesn't exist anymore. We can just delete it from the hash map. And that's a little bit better. But now this is still n. So let's submit this. Leetcode's been really slow recently. Okay, so a little better. So this is still n. So what we're going to do is just create a, well, so now notice that whatever second is reflected in C. So instead of remove every time, you can just say we have a middle, right? And then for A, B, and C dot items, so y is b, this is the frequency, while y is bigger than 0, mid plus equals to that letter that many times. So doing this, and then we just plus mid instead, because this is a string, right? So let me show you what that is. So let's, if we print second and C, you can see that they're the same thing, right? They just, exactly, that's the dictionary reflecting the status. So the character and how many times it appears in second. So we don't need this. And that's going to save some time. So let's submit this. And there you go, passes all test cases. Again, I'm really happy that I was able to solve this one on my own without any assistance, even though it's not the most efficient in terms of time and memory. But that's it for this video. Thank you for watching and stay tuned for more.